I'm not good at math. I don't understand what I'm ever going to use this math for. Are these things you have said or heard other students say? Sadly, a lot of students move from elementary through high school feeling that way. When Raytheon Corporation asked 1,000 middle schoolers if they'd rather eat broccoli or do a math problem, a majority said broccoli. The confusing thing is that math relates to every aspect of our lives, so why do so many students and adults feel that they are no good at math? Think about what is happening right now in your body. You have a heart rate, blood pressure, white cell count, body mass index, all things that are measured with math. The computer game you love is the result of some pretty complex coding. There's math. The calories contained in a candy bar and the calories you burn while running. There's math. The blast-off of a rocket, its orbit around Mars, and the landing of a Mars rover. There really is math. In order to help students feel more engaged and confident about math, research stresses the importance of connecting what happens in a math class with real-world applications. This is where Autodesk can really help you. We do this by first giving you free access to the digital tools and skill-building tutorials that will enable you to quickly learn how to apply mathematical reasoning to the types of situations you will find in the real world. In addition to providing you with powerful digital tools and skills, we know it is critical that you also have a strategy for using them effectively. That is why all of our projects are structured around a set of reasoning or planning strategies called design thinking. So let's look at a quick example of how design thinking might help you to apply mathematics to solve real-world problems and innovate new solutions. In geometry, you are asked to think about circles, circumference, radii, diameter, radians, angles, degrees, seconds. What if, in addition to studying the text or watching a video, you were asked to apply your geometry knowledge by assembling and programming a robot? In the initial understand stage of the design thinking process, you want to get a handle on the problem or challenge you will be working on. This may come as a teacher assignment, or perhaps some problem or challenge that you have identified. In the explore stage, you will be trying to get a handle on the relevant geometry concepts that impact the design and performance of your robot. You might start by referencing textbooks or online interactive simulations. Or look at streaming videos about robots from the VEX Robotics projects in the Digital STEAM Workshop. In the define phase, you are essentially determining the criteria that you need to consider in developing robots. The ideate, prototype, and refine stages are where Autodesk resources can really decrease the time, skills, and resources you will need to get the job done. You might develop several robot designs using 123D design. Using Autodesk Make, you can create plans for building the frame of the robot. Based on these plans, parts can be quickly produced using 3D printing or laser cutting technologies. With your parts assembled, you get to test out the prototype. After testing and refining a prototype, you are ready to make a pretty impressive presentation where you can describe your understanding of geometry concepts by showing how they relate to the design and performance of your robot.